So you have seen that 5 minus root 3 is an irrational number. Now, even if you have multiplication, like you have to show that 3, suppose you have to show that 3 root 5 is an irrational number. Show that 3 root 5 is an irrational number. So here also the second method will be applied. Let proof will be contradictory proof. So let root 3 root 5 be a rational number. Be a rational number. Then we can write 3 root 5 is equal to P upon Q, where P and Q are co-primes, where P and Q are co-primes and Q is not equal to 0. Here it is simple. 3, just you have to transpose 3 on right hand side. Left hand side only root 5 will be left. P upon 3Q. Actually P, here we should also mention that P is an integer or prime number. P is an integer and 3Q is also an integer. So when integer upon integer implies that P upon 3Q is a rational number. So again, we reached to the conclusion that irrational is equal to rational, which is impossible. So we are having left hand side is irrational number. Root 5 is an irrational number. Left hand side, and right hand side we are getting rational number. Right hand side is a rational number, which is impossible. Which is impossible. Therefore, or this is a contradiction, and this is a contradiction. Our supposition was wrong. Hence, prove that 3 root 5 is an irrational number. Is an irrational number. Okay, got it? Question number 2, exercise 1.3. 3 plus 2 root 5 is irrational. This we have to prove that it is an irrational number. So same way we will go by the same procedure. Let 3 plus 2 root 5 be a rational number. Be a rational number. Then when it is a rational number, it must be equal to P upon Q, where P and Q are co-primes and q is not equal to 0. Now you can solve. You have to leave only root number left hand side. All other numbers you will bring on right hand side. So plus 3 will come here. It will become minus 3. So 2 root 5 is equal to p minus 3q by q, and this 2 also will be transposed on right hand side. We will get root 5 is equal to p minus 3q upon 2q. So this is right hand side is rational, left hand side is irrational. So it is irrational number, and right hand side is a rational number. You can elaborate that p minus 3q is an integer, and 2q is also an integer. Therefore, the ratio is a rational number, which is a contradiction, which is a contradiction. Hence, in short, you can write like this also, which is a contradiction. Hence, 3 plus 2 root 5 is irrational. Okay, got it? Exercise, the same exercise, 1.3. Like question number 3, first part, 1 by root 2. So 1 by root 2. Let 1 by root 2 be a rational number. It is a rational number. Then 1 by root 2 will be equal to p upon q. Now here you have to multiply and divide by root 2 so that root will come in the numerator. Root 2 into root 2 p upon q. So this will become root 2 2p by q. So similarly, left hand side is irrational, and right hand side is rational. This is a contradiction, which is a contradiction. Hence, 1 by root 2 is irrational. So this is all about this exercise 1.3. Sometimes question asked like this. This was asked in 2012. Prove that. First, we have to prove that root 3 is an irrational number. We are taking some.
So this is extra questions? Okay.
So prove that under root 3 is an irrational number. Yes, extra question. Which was asked in board 2012. So see that. Prove that under root 2 is an irrational number. So here we have to prove under root 3 is an irrational number first. And hence show that, means after proving under root 3 is an irrational number, you have to prove that 7 plus 2 root 3 is also is also an irrational number. Okay. So actually we have given two proofs, first part, second part. So we can do first part and then second part. So as I told you, let root 3 be a rational number. Then root 3 can be written as P upon Q, where P and Q are co-primes. P and Q are co-primes and Q is not equal to 0, and squaring then both sides, squaring we get 3 is equal to P square upon Q square, or it can be written as Q square is equal to P square by 3, and which shows that 3 divides P square. When 3 divides P square, it shows that 3 divides P also by theorem. 3 divides P. When 3 divides P, we can let P is a multiple of 3. So we can take 3m, let P is equal to 3m, where m is any integer, where m is any integer. Then put this value in equation number, this one. We can say this is equation number 1. So put in first P square. So Q square will be equal to 3m whole square divided by 3, or we can write Q square is equal to 3 square means 9 divided by 3, again 3m square, and this 3 we can write left side. So we can write Q square upon 3 is equal to m square, which shows that 3 divides Q square. That means 3 also divides Q also. So when therefore P 3 divide both, which shows that 3 divides both P and Q, which shows that P and Q are not co-primes, and which is a contradiction. Which is a contradiction. Therefore, root 3 is an irrational number. Is an irrational number. Okay. Second proof, same I told you, is you have to write let 7 plus 2 root 3 let be a rational number. Then 7 plus 2 root 3 can be written as P upon Q, where P and Q are co-primes and Q is not equal to 0. Q is not equal to 0, and solve this. We get 2 root 3 is equal to P by Q minus 7, or we can write root 3 is equal to p minus 7q upon 2q. It is irrational. Left hand side is irrational and right hand side is rational, which is a contradiction, which is a contradiction. Therefore, 7 plus 2 4 3 is an irrational number.